Welcome to the lecture on absolute value equations. We're going to be talking about how to solve equations that involve absolute values. The first thing that we need to know is a theorem that basically says that if a is a positive number, then the absolute value of x equals to a means or is equivalent to x equals positive a or x equals minus a. Here's a simple example that demonstrates that. If we have the absolute value of x equals to 3, then what this theorem basically says is that we have two solutions. X could be positive 3 or x could be minus 3. And the reason why that's the case is because if you take the absolute value of 3, you'll get back 3. And if you take the absolute value of negative 3, you'll also get back 3. So there's two possible solutions, the plus and the minus case. When we write out our final solution, a lot of times we'll write it as a set, and we can even use the plus or minus symbol and just write the set plus or minus 3. It's also correct to just write it as x equals 3 or x equals minus 3. So in the next example, we're going to slightly complicate the problem because now we have an expression inside of our absolute value symbols. But in terms of how we solve this, we're going to do it exactly the same way. We're going to split this up into the two possible cases. Either this expression inside of the absolute value is equal to positive 6, or the expression inside is equal to negative 6. So you're always taking this number on the right-hand side, the plus and the minus case of that. And now we just have to solve each of these two individual equations, and that'll give us our two solutions. So if we subtract 1 from both sides, we get 3x equals 5. So one solution is 5/3. And if I subtract 1 in the second equation, we get 3x equals negative 7. If I divide through by 3, then x equals negative 7/3. So these are my two solutions, or again, you could write it as a set, 5/3, comma, negative 7/3. Okay. In the next two examples, we're going to do the same thing. However, notice that the absolute value equation isn't isolated. So in this case, there's this plus 1 off to the side, and in this equation over here, we've got a coefficient of 3 and also a plus 2 off to the side. So what you need to remember first is always isolate the absolute value. And you want to do that first before you split up your equation into the two possibilities. Okay, so for example, if I have absolute value of 2x plus 1 equals 6, I want to isolate this absolute value first, so I can just subtract 1, and that'll give me the absolute value of 2x equals to 5. Once I have the absolute value isolated, then I get to break it up into the two possibilities. Either 2x equals positive 5, or 2x could equal negative 5. And then if I divide both sides by 2, we get two solutions, 5/2 or negative 5/2, or if I write it as a set, plus or minus 5/2. Okay, in the next example, we're going to do the same thing, but we have a little bit more cleaning up to do. Notice on the right-hand side, there's also an absolute value. However, what's inside of it is just a number. There's no x's in there. So I can actually simplify the absolute value of negative 8, and you want to do that first. Absolute value of negative 8 turns into positive 8. So if I simplify that first, and then I try to isolate my absolute value, I'm going to want to probably subtract that 2 first, and that'll give me 3. Absolute value of x minus 2 equals 6. And then to get rid of that coefficient of 3, remember that it's being multiplied by that absolute value, so I can divide through by 3 to isolate that absolute value of x minus 2. So I get absolute value of x minus 2 equals to 2. Once the absolute value is isolated, then you split it up into your two cases. So either x minus 2 equals positive 2, or x minus 2 equals negative 2. If I add 2 to both sides, then I'm going to get 4 for this case and 0 for this case. So my two solutions are 4 and 0, or the set 0, 4. Okay, so in these first four examples, we were solving an absolute value equation set equal to a positive number. in this one had a negative 8, but it was an absolute value, so it turned into a positive 8. So all 4 of these had a positive number on the right-hand side of that equation. So that's one case. The next case that we're going to look at is when the number on the right-hand side is a 0. So if we look at absolute value of 2x minus 3 equals to 0, there's only one way we can split this up. If we try to set this equal to the number on the right-hand side and its opposite, well, the opposite of 0 is still 0. So these are going to be equivalent expressions. So we really only need to set that expression equal to 0, and we're only going to get one solution instead of 2 when the number on the right-hand side is 0. So if I solve for 0, I'm going to get 2x equals to 3, so x equals 3 halves. So we get the set 3 halves. So again, if you're setting an absolute value equal to 0, there's only going to be one solution this time instead of 2. So if we have absolute value of 5x equals to 0, the only way that can happen is if 5x equals 0 without the absolute value. And if I divide both sides by 5, 0 divided by 5 stays 0, so my solution is just 0. Okay, so when you have a positive number on the right-hand side, you'll get 2 cases and 2 solutions. When you have 0 on the right-hand side, you'll only get 1 case and 1 solution. So what happens when you have a negative number on the right-hand side? That's what these next 2 examples are. Well, if you think about this a little bit, remember that an absolute value takes whatever your expression is in here and it's going to make it positive. So the absolute value of 5x plus 1, this is always positive, no matter what you choose for x. So if the left-hand side is always positive, there's no way it can ever equal a negative 3. So this has no solution, and we don't have to do any solving at all. We just recognize that there's no way an absolute value can equal a negative number. So if I look at this next example, as soon as I see that negative 6 on the right-hand side, I know that the absolute value of anything can't be negative 6, so this just must be no solution. So we either have no solution, one solution, or possibly 2 solutions. Okay? The last type of absolute value equation that we're going to be working on is when you have absolute values on both sides of the equation, and both absolute values are involving x's. So in this example here, we have absolute value of x minus 2 equals absolute value of 2x plus 1. In order to solve this, we're going to separate it into our 2 cases, just like we did these earlier problems up here, where we set it up into the positive and the negative case. So that's what we're going to do here as well. So what I usually do is I choose one of these, usually the left-hand side, to remain the same. So I'm going to leave x minus 2 as x minus 2, but it could equal either the positive case of 2x plus 1, or it could equal the opposite of 2x plus 1. And notice how I'm writing that. I'm putting the minus sign out front of parentheses wrapped around my 2x plus 1. So either the x minus 2 equals positive 2x plus 1, or it equals negative 2x plus 1. So we're considering both cases. Now we just have to solve each of these and we'll have our 2 solutions. So in the first case, I'm going to get my x's together by subtracting x. Then I'm going to subtract 1, and I get negative 3 equals to x. So there's one of my solutions. For the second case, please make sure that you distribute that negative across first. So we'll get negative 2x minus 1. Then I'm going to get my x's together by adding 2x. So I get 3x minus 2 equals negative 1. Add 2, and we get 3x equals to 1. Divide by 3, and we get x is 1/3. So my 2 solutions are negative 3, comma 1/3. Okay, so if we try another example like that, remember if you have 2 absolute value expressions on both sides of the equations, you're just going to split this up into 2 cases. I tend to leave the one on the left side alone and not change it at all. So x plus 3 equals positive 3x minus 4, or the opposite of 3x minus 4. So this is how we're going to get our 2 solutions. So if we solve the first one, I can subtract x, get 3 equals 2x minus 4. Add 4 to both sides, so we get 7 equals 2x. Divide by 2, and one solution is 7/2. For the second case, distribute your negative across first, so x plus 3 equals negative 3x plus 4. Add 3x to both sides, so 4x plus 3 equals 4. If I subtract 3, we get 4x equals 1, and if I divide by 4, I get x equals 1/4. So my two solutions are 1/4 and 7/2. Okay? The last two examples here, just kind of mixing it up a little bit. Again, I have initially here two absolute values, but what you want to notice about this problem compared to the last problem is the absolute value on the right-hand side does not contain any x's. So that means this right-hand side can be simplified. What's the absolute value of negative 6? It's positive 6. So we don't actually have an absolute value on the right-hand side, just on the left-hand side. So when we go to solve this, once we have it simplified and we have this absolute value isolated, because there's a positive number on the right-hand side, all we have to do is split this up into our two cases. The expression inside the absolute value equals either positive 6 or it could equal negative 6. Now because I have fractions in both of these cases, I can get rid of the fraction by multiplying both sides of the equation by 2, whatever that denominator is. And 2 divided by 2 cancels out, so on the left-hand side we'll just get 5x plus 2, and that denominator goes away. And on the right-hand side, 6 times 2 is 12. If I subtract 2, we get 5x equals 10, so one solution is going to be 2. Doing the same thing for the other equation, let's go ahead and multiply by 2 again. We cancel out our 2's on the left side, and so on the left side we just get that numerator, 5x plus 2, and negative 6 times 2 is negative 12. If I subtract 2, I get 5x equals negative 14. Divide by 5, so my second solution is negative 14/5. So I get 2 comma negative 14/5, and I'm done. Okay? On the next example, same idea. We have an absolute value expression on the left side, and that side has a variable in it, but on the right-hand side there is no variable, so we should be able to simplify this. Now when you go to simplify this, notice that you're not allowed to cancel out these two negatives. The absolute value bar here is like a grouping symbol, and according to order of operations, we need to simplify this absolute value first before we multiply by that negative 1 on the outside. So what does the absolute value of negative 9 become? It becomes positive 9. The negative that's out front here stays out front. So this turns into the absolute value of 5d plus 1 all over 6 equals to negative 9. So there's no more absolute value on the right-hand side. Now, before you immediately break this up into two cases, you actually don't want to do that, because think about your problem. We have an absolute value. When does it ever equal a negative number? Never. So this has no solution, and we don't have to do any work at all. Okay? So these are our cases for solving absolute value equations. On this last page, I just have a summary of all the different cases that we've done. If you have an absolute value expression set equal to a positive number, so here a is positive, then you just separate this into your two cases, set your expression equal to positive a or your expression equal to negative a. If you have an absolute value set equal to a negative number, then there's no solution. You don't have to do any work, because there's no way that an absolute value is ever going to be negative. If you have an absolute value set equal to 0, then there's only going to be one case, and you get it by just setting your expression equal to 0 and solving. So we either have two solutions, one solution, or no solutions, depending on whether the number on the right-hand side is positive, negative, or 0. And the last possible case is if you have absolute value expressions on both sides, where there's variables involved in both absolute values. In that case, you're just going to take expression 1 and set it equal to the positive expression 2, or take expression 1 and set it equal to the opposite of expression 2. And make sure to distribute your negative across before you simplify. Okay, that's all your cases. Good luck. That concludes our notes on the absolute value equations.